Okay, I'm going to try and attempt and show you a bit of implicit differentiation. This is for AQA Core 4, but I think that EdXL and OCR do it as well, but I wouldn't know because I'm doing AQA. This is from the June 2007 paper, and it's question 5. Now in part A, as I showed you in the snapshot, I'll show you this here. It says show that A equals 1. That's fairly simple to work out, it's just a bit of substituting in. But I'll skip straight on to B, which is find the gradient at curve P, which, as you'll see, is 7 marks. 7 marks! So if you get that wrong, you're a bit screwed if you want a high mark. So, well, unless you can do everything else, but never mind. So we've got the curve here. Now, to differentiate that, it's a bit difficult. So, first of all, we're going to get everything equal to 0, so that it's a bit easier to work with. And I'm going to keep these ones there as a plus, because you've got to do the product rule later. So it's a bit of a pain if that's a minus, and it's just easier in general. So, we make that 5x squared, y squared. Bring the 4 over, which makes it a minus 4x. And minus the y. Now we're going to look at each of these terms separately and differentiate them accordingly. So first we're going to ignore the rest of this and we're going to look at just the 5x squared y squared. It's the most like rubbishy, horrible bit of the whole thing, I think. So we're going to call this 1. So 1 here, this is the first sort of block of terms, because you can't really separate these out, so you've got to use the product rule, which is dy dx of uv is equal to u dv over dx plus v du over dx. So that's basically you label your terms, which I forgot to do, as u and v. Doesn't really matter which way you put it around, but no, I'll just do it that way anyway. And then so you've got to leave u, differentiate v in terms of x, and then you've got to leave v and differentiate u in terms of x. Now this can be slightly difficult unless you know what you're doing, because you've got y here, but we'll come back to that later. So the 5x squared, now that's your u, so you're leaving that first. So you've got 5x squared. That's fine because that's just u. Now dv over dx. Because you've got the y squared here as your v, you can't differentiate that in terms of x. So you've got to use the chain rule to get that so that you can differentiate it properly. So if we can just come down here for a second as a little aside, I'll do it in red to show that it's a bit different. So you're trying to differentiate the y squared. So if you put y squared as the function, this is completely separate from everything else, so it's just working out so that you can get the term. You're trying to find df over dx to differentiate that. So if we use the chain rule, df over dx is equal to df over dy times dy over dx, because these two here, this one and this one, because these two cancel out, make dy over dx. So if you're doing core 3 as well, which I assume you will be, you'll know the chain rule anyway. So df over dy, we can do that because it's in terms of y. So we just differentiate y as if it's as you normally would anyway. So df over dx of y squared is equal to just 2y as you normally would, but it's times dy dx, but that can just stay really. So it's 2y dy over dx, and that's that first, that's that v dv over dx that you're looking for. So we can come back up here. Sorry if I'm confusing you. So we've got this dv dx here now, so we can put that back into there. So we've got 5x squared times 2y dy dx. and then we've got to plus the v du dx. Now this is easier because obviously we're leaving the v, which is the y squared, so we've just got y squared in there, and du over dx is literally just 10x because of you've got the first term here, so that's just y squared 10x. Yep, so that's your first bit done. You can do that and put that in. Now the next bit here is your minus 4x, so we'll call that 2. Now that's literally just, you know, put 2 over here. That's literally just in terms of x, so that's f equals minus 4x. Df over dx is equal to minus 4. So that's your second one done, really. So that's fine. We've done 2 here, and then with the minus y, with the minus y, column number 3, you do exactly the same thing as we did before, but it's simpler because we're not having to use the product rule. So we're just using the chain rule to do that. Do that here. We've got f equals minus y, and so we've got the minus y here, so df over dx is equal to df over dy times dy over dx. So you differentiate that as you normally would, so that just goes to minus 1. So you've got minus 1 dy dx. So that then just goes into minus dy dx. So then we can put that back into the equation. We can group all of these terms that we've done separately, that's in a way, and put it back in as a differentiated form of the equation now. So that means that finally, well not finally, we've got a bit more, but we can get an easier form, which means that we now have 5x squared 2y dy dx plus y squared 10x, and then we've got number 2, so minus 4, and number 3 minus dy dx. Now I've got that long thing here, so we need to simplify it down.